Hello, everybody. Today we're going to be going over critical points of functions. Critical points of functions are essentially the points of a function in which the slope is zero. The slope tangent to the curve is zero, otherwise known as the first derivative is zero. So that's the exact thing that we're talking about is that the reason in which we do the things we do for this specific topic is because we are saying that our tangent lines, or our tangent lines that are tangent to the curve, have a slope of zero. And that'll relate to them being a maximum or a minimum. Maximum being the highest point and minimum being the lowest point. Now, hopefully you're familiar with the term relative and or local. That is on an interval. That would be, but we're not going to discuss that today. We're going to just discuss our absolute, or we're going to discuss relative, but we're not going to discuss absolute over an interval just yet. So let's say we have a function. Let me get out my pen. Is equal to negative 2x squared plus 4x plus 8. Okay? And we want to find the critical points for our relative extrema. All that means is that we're trying to essentially just find the extremes of the function, the highs and lows. That's what extrema means. So the way we do that, as we discussed, is we want our first derivative to equal 0. So f prime of x equals 0. So when you take the first derivative of this function, you get negative 4x plus 4, and you're going to set it equal to 0. So you're going to set the first derivative equal to 0. And in this case, you get x equals 1. This is our only critical point for this function. So let's make a table to find the intervals of increasing and decreasing. So if we have 1 on this side, we want to plug this into f prime of x. And we want to find the intervals of increasing and decreasing so that we can graph this function. So a number that's less than 1, like 0, will produce a positive result. And the number like, let's say, 2 will produce a negative result. So this means that on the interval from, so that means from negative infinity to 1, it's increasing, but from 1 to infinity, it's decreasing. Now, related to the graph of the function, let's find the concavity. The concavity is just setting the second derivative equal to 0. So a second derivative is just negative 4, and we don't need to set that equal to 0. All this means is if you get a number, you just check if it's greater than or less than 0. In this case, it's less than 0. So that means it's always concave down. And you can see, and you can verify that because this term right here signifies what direction the parabola is going to be in, whether it's greater than 1 or greater than 0, sorry. So let's specify our critical point. So if we plug in x equals 1, we get negative 2 times 1 plus 4 plus 8. In this case, this is equal to 10. So our critical point is at 1, 10. Okay? And we have to find whether this is a minimum or a maximum. And how we test this, we have to essentially say, well, we looked at our intervals of increasing and decreasing, and it goes from positive and then it goes to negative. So this is in fact a maximum. So just analyze what happens here. So it's increasing up, it's going up, and then it hits a maximum of 1, and then it starts going down. So just think of it that way. And if the symbols were reversed, we would have concave up, because it'd be decreasing down all the way to 1 and then increasing from 1 to infinity. So in this case, this is a max. This is a maximum. So if we were to graph this function, let me create a little graph. So imagine we have a critical point 1, 10 here. The function would look something like this. We're definitely redrawing that. That's good enough. You get the idea, though. This point right here, as you can see, the slope of the tangent line is equal to 0. And this is significant because when the slope of the tangent line is 0, we either have a minimum or a maximum. And in this case, this is the absolute maximum of this function, is at 1, 10. Okay. Let's try another problem. Let me erase this. We'll see. What kind of... All right, well, we'll keep the graph down here. All right, so for this problem, let's find the intervals of increasing and decreasing, the concavity switches, if any, and let's graph the function. So our first step is to take the first derivative, so f prime. This is going to be negative 3x squared plus 6x. We're going to set that equal to 0. Okay. Let's do a little bit of factoring magic. Negative 3 times x is equal to x minus 2, in this case, because the negative 3 and the negative 2 combine. So x is equal to 0 and x is equal to 2 are both critical points on this graph. So now let's find the areas of increasing and decreasing. So here we have 0 and here we have 2. Let's see what happens in each of these regions. So any number that's less than 0, if we, for example, plug in, if we plug in negative 1, we get negative 1 to the third, negative 1 to the third, plus 3, because negative 1 squared is just 1. So this is just 1 plus 3, which is equal to 4. So we're going to get a positive number. Hold on a moment. Need to be plugging this into the f prime. I need to be plugging this into the f prime. So if we plug in a negative number, and in this case, we're going to get negative 3 plus, we're going to get negative 3, and then we're going to get minus. Okay, so it's actually going to be negative to start out with. And then between 0 and 2, if we choose a number like 1, we'll get a positive number. Now let's choose a number greater than 2, such as 3. So if we choose negative 3, I'm not completely sure why it's doing that. Yeah, I did not select that, but all right, I guess we're going to use green now. 3 times, or sorry, negative 3 times, we'll choose 3 squared plus 6 times 3. This is going to be a negative number. All right, and remember that for our things here, we have negative infinity, and infinity is what we're going to go off to. So this is the intervals of increasing and decreasing. Now, let's go over and find the concavity switches, if any. So, f prime prime of x, it's going to equal negative 6x plus 6. And let's set that equal to 0. And we get that x is equal to 1. Has a concavity switch of the function. So, let's actually find all of our critical points. So, right after, we're just going to make that is an absolutely abysmal table. Yeah, so we can just make this small table. And at x equals 1, we're going to have, let's see. So, if we plug in a number like 0, we're going to have a positive concavity. And then, obviously, if we plug in a number larger than 1, like 2, we're going to have a negative concavity. So that's how it's going to change. Okay? So, now we just take this all into account, and let's find the actual points. So, if we plug in x equals 0 to the original, we're going to get 0. So, y is equal to 0 as well. And if we plug in 2, we get negative 8 plus 12, this is 4. And then, for concavity, it's at x equals 1. And when x equals 1, y equals negative 1 plus 3, which is 2. So, this will be at 2. At 1, 2 will be the concavity switch. So now we're ready to graph the function. So, imagine, I'm going to use my critical points in blue. We'll use 1, 2, we'll say is right here. At 0, 0, we also have a critical point. And actually, what I'll use a different color to notify the concavity switch versus the actual critical or the actual extrema. And in this case, it's going to be relative, and you'll see why. And the next critical point is 2, 4. So 2, 4. It's about right there. Let's delete this other miscellaneous point. So now all we have to do is that we just simply graph this function by plotting or by going or following the rules that we found from our thing. So our concavity goes down. It starts down. So it starts down, and then when it hits, and then hold on a moment. No. This is going to be not our concavity. Our concavity starts positive. So we're going to have something like this. And we're going to have a function like this. And here's why. It's because our concavity right here changes at this point right here. So as you can see, we go from positive to negative concavity. Or sorry, we go from positive concavity, and then we'll have negative concavity. I'm not quite sure why I did this. Hold on a moment. Let's rewrite this. Let's say 2, 4 is like right there. So we said that the concavity is negative past 1, so let me rewrite this, okay? Okay, there we go. So this, as long as we erase this, of course. This is, in fact, how this graph looks, relatively speaking. Because our concavity changes, we have an up concavity here. It's all facing up. And as soon as we hit this point, everything starts facing down. And as you can see from our intervals of increasing and decreasing, they match up. Anything less than 0 is decreasing. But then it starts increasing from 1 to 2. And then as soon as it hits that concavity, or as soon as it hits that concavity point, we start, or as soon as it hits that concavity, it starts decreasing right after we hit that last critical point. Anyways, hope you like this video. I'll be taking video suggestions in the comments for this video and for all future videos. Drop the comments below, drop the suggestions, and I'll see y'all later. Goodbye.